In today's class, we will talk about sample regression function SRF. Let's put the heading. Okay, now similarly for population, as we take for population regression function, we will take for sample regression function. Here is income X, and here will be expenditure Y. Now, suppose we have only one value of y corresponding to given xi. These are x1, x2, x3, and x6. Now, sample regression line will be like this. Now, the objective, what is the objective of sample regression function? Objective will be the data to be best fit on the line, that is like this. The objective is that the value we get actual the value estimated or average value is must be on the line, or like maybe above actual value, not far away but nearby, maybe like this, maybe like this. Okay, but the objective is to best fit on the line, best fit, or we can say that best fit to the given data. Now, since sample regression function is line, similarly population regression function, it also be linear, and it also mathematically it also can be drawn as a linear function, and the linear function will be I uh, in population regression we call this point as a expectation y governed by xi. Now here we will call it yi hat. Hat means hat is for sample, that is we are talking about sample, that's why we take it as hat. Now this is also y1, y2, y3, and this point on the line, this point on the line is yi hat, y2 hat, and y6 hat. The outside may be like in the previous one, the no difference, but it we are here talking about sample, and there we are talking about population. Okay, so these will points will be y actual values, y1, y2, y3, y6. Now yi hat will be beta 1 plus beta 2 xi. Now here, what is b1? Sorry, I think I pronounce it beta 1 and beta 2, but it is b1 and b2. So what is b1 and b2 here? b1 and b2 are the estimators of b1 and beta. Okay, b1 we can also write b1 as beta 1 hat, or b2 as beta 2 hat. and this one is estimator of beta 1 and this is estimator of beta 2. Now can you please tell me the population regression function equation? What is that? That is expectation of y governed by xi. Yi xi, you can write anything as you wish, is equal to beta 1 plus beta 2 xi. Now here b1 is estimator of beta 2. Oh, b1 is estimator of beta 1, b2 is estimator of beta 2, and xi is as it is. And now yi hat is estimate of expectation of y governed by xi. So yi hat estimator of xi. This is all about sample regression function. Now we will talk about stochastic specification of sample regression function. Stochastic specification of sample regression function, which is SRF. Now we have yi. Here yi will be yi hat. Now this is actual expenditure, this is estimated or point on sample regression function या फिर और sample regression line, like I have drawn like this. Then these points are yi hat, so this is point on SRL. So now can this be equal? No. Yeah, maybe, but not every time. So in the population regression function PRF, we added an error term, that is UI. Similarly, here we add the term EI, and here we call it residual term. Now what is yi hat? b1 plus b2 xi and ei as it is. Now b1 is an estimator of beta 1, b2 is an estimator of beta 2, ei is an estimator of speak ui, estimator of ui, or we can calculate it, we can say ei also ui hat, same thing. It is a small u, not capital. Okay, remember this. b1 is an estimator of beta 1, b2 is an estimator of beta 2, and ei is an estimator of ui. Now I will write some conclusions here what we read previously. Uh, Now in PRF, what we first calculated, that is Ey by xi, which is equal to b1 plus beta 2 xi. Then yi is equal to sorry, expectation of y given by xi plus ui. Then we can also say it beta 1 plus beta 2 xi plus ui. We derive these three things in population regression function. Now in SRF, what we derived, uh, yi hat is equal to b1 plus b2 x, yi is equal to yi hat plus ei. Therefore yi can be written as b1 plus b2 xi plus ei. Remember this, here I used y and x capital. Remember this. If someone not clear about my handwriting, then it is y and capital Y and capital X. This is small b1 and small b2. This is small ei. This is small ui, and this is beta 1 and beta 2. Okay. Uh, when we go ahead, we will use small x and small y. That's why I tell you about it. Okay. Now, sample regression function and population regression function, now it's over. Now we will talk about very important method, that is ordinary least square method. We also called it OLS method. Okay. Now ordinary least square method, OLS method. Now listen me carefully. You can also write its definition, but I will tell you simply. In this method, we will minimize summation of ei square. We minimize summation ei square. We have to minimize that in this method. Now you can write definition also. OLS method states that b1 and b2 to be selected in such a way such that summation ei square is minimized. So according to definition, and in this method we have to find b1 and b2 such that summation ei square is minimized. Simple language. In simple language, what is meant OLS method is this. Now I will come to the derivation. Wait a second. Okay, so sigma ei square, what we can write? Sigma, what is ei? Ei is in sample regression function, which is a residual term, and ei will be I'll let you know that yi is equal to yi hat b1 plus b2 xi plus ei. Now from there ei will be yi minus b1 minus b2 x. So substitute this here, yi minus b1 minus b2 xi whole square. Okay, so now we have to minimize it. So we will differentiate it with respect to b1 and b2. We have to find b1 and b2 value such that sigma summation of ei square is minimized. So we will differentiate it with respect to b1 and b2. So first differentiate it with respect to b1. Summation 2yi minus b1 minus b2 xi and minus 1. So minus 2 will come outside and summation will be yi minus b1 minus b2 x. And what is yi minus b1 minus b2 xi? Ei. Now differentiate the ei summation of ei square, that is this, with respect to b2. Now I do it direct. 2 summation yi minus b1 minus b2 xi and minus x. So minus 2 summation ei x. This will become ei and this xi, and this minus will come outside. Okay, so now consider this. Remember this in mind, that we have to minimize summation ei square. So put first derivative with respect to v1 is equal to 0 first. Wait a second. I compact this, but I will use this one. Okay. So summation, this implies summation yi minus b1 minus b2 xi is equal to 0. Now summation, open the summation yi minus n b1 minus b2 summation xi is equal to 0. Its summation of constant b1 is a constant, summation of b1 is n times b1, and yi will be in summation and xi will be also summation. b2 is also a constant, then it will come outside the summation. So now what will be summation yi? Summation yi is n b1 plus b2 summation x. Okay, this is an important equation. Let me tell you after this derivation what we call the from this we also got one more equation, and both the equation what I will tell you what we call them. So in this case also put this one is equal to 0. This one I used to simplify this one to show you what we called is as, but you cannot use we will use this one. Okay, uh, so equal to 0, which implies summation yi minus b1 minus b2 xi is equal to 0. Now open this summation xi yi minus b1 summation xi minus b2 summation xi square is equal to 0. This case summation xi is yi is equal to b1 summation xi plus b2 summation xi square. Now 1 and 2, these two equations are called normal equations. These two equations are called normal equations. Now we have to remember this, we have to calculate b1 and b2, but these derivations are useful later on. Now I will rough the board, because now I derived these two equations and I need these two equations. I have no work from the derivation now, so I will rough this. Okay, now from equation first. Sigma y is equal to nb1 plus b2 sigma xi. Oh, sorry, I called summation sigma, but it's not sigma. It is summation. Sometimes I'll call it sigma, but not sigma. Not called it sigma. It is summation. Summation xi. Now divide both sides by n. Then what it will become? This will become y bar equal to b1 and b2. This part will become x bar. Now from here we will find the value of b1 y bar minus b2 x bar. This is equation third. Substitute equation third in equation 2. What we will get? summation xi y is equal to b1 is y bar minus b2 x bar summation. Substitute this in this uh, sigma xi or summation xi plus b2 summation. Actually we called it sigma, but here if I called it sigma also, you will be confused from this sigma and this sigma. This is also called sigma, so it is summation. b2 summation xi square. Now on the bracket y bar summation xi minus b2 x bar summation xi plus b2 summation xi square. Now take this in this side and from here take b2 common. From here b2 will be can I see the what? Yes. This will be b2. Now what we have to find is b1 and b2 mainly. We have what is OLS method states what? It states we have to find the value of b1 and b2 such that summation ei square is minimized. Okay. So now one further steps from here is we can write b2 is summation xi yi upon summation xi square. Where xi is equal to xi minus x bar and yi is equal to yi minus y bar. So how it comes to this, I will derive this for you. You can write it as a remark. Now सॉरी यहाँ पर हम P2 को summation xi माइनस एक्स बार एंड yi माइनस y बार बोल सकते हैं और यहाँ पे हम summation को xi माइनस एक्स बार का होल स्क्वायर बोल सकते हैं। तो यहाँ से ये चीज कैसे आई, इसको तो हमने इसमें लिख दिया, इसको तो मैंने ऐसे भी मीन्स आई ऑल्सो राइट दिस एज xi माइनस एक्स बार एंड yi माइनस y बार। This is same thing, but how this will come from this, I have to write that. Okay, so you can write it as a remark, and after this will come, and after this will come. Now summation xi minus x bar and yi minus y bar, what it is. Open the summation xi yi minus summation xi yi minus xi y bar minus x bar yi plus x bar y bar. Summation xi yi minus summation xi y bar minus summation x bar yi plus summation x bar y bar. So summation xi yi minus xi minus x bar summation yi and summation of what will it will be constant. So we can write it as n x bar y bar. Now here divide and multiply by n, divide and multiply by n. So what it will become, n y bar x bar minus n x bar y bar minus n x bar y bar o plus. So one will cancel, and this is wait a second, is there any mistake? Sorry, not take here, this will be y bar x. So this is same. Now for this, here will be xi and x bar, xi and x bar. So you can replace the term from yi to xi and y bar to x bar. What will come? xi x bar xi. I think board will not be visible. Summation xi square minus xi summation x bar summation xi, and this is exactly the same. So this, I hope this will be clear to us. Now this is all about ordinary least square method. After this there will be properties of this method that we will cover in next class. Thank you so much.